Hey everyone, and welcome to this explainer. Today, we're laying down the absolute essential foundation for understanding a true marvel of modern engineering and transportation: high-speed rail. If you've ever wondered what it actually takes to build, maintain, and run these incredibly fast networks, well, you're in exactly the right place. We're going to build our understanding from the ground up, starting right here with Chapter 1.
So, picture this. How does a country with one of the absolute largest railway networks on the entire planet have absolutely zero high-speed trains? It's kind of a staggering paradox, right? We're talking about India, a nation with this incredibly vast, historic rail system that literally moves millions of people every single day. Yet when it comes to the cutting edge of high-speed travel, it's been notably missing from the global stage. That stark reality is exactly what we're going to unpack today.
Okay, let's dive into this. Here's our roadmap for today's explainer. 1. The global need for speed. 2. India's high-speed opportunity. 3. Coordinating the global network. 4. Anatomy of high-speed rail. And finally, 5. The passenger experience.
Kicking things off with Section 1, the global need for speed, from post-World War II to the present.
You know, high-speed rail isn't some new experimental concept. It's actually a mature, global phenomenon. The idea really started developing worldwide right after World War II, with Japan taking that crucial initial lead. Then, between the mid-1950s and the 2000s, so we're talking a period spanning more than 50 years, several European countries like France, Germany, and Sweden followed suit. They clearly saw the immense advantages of high-speed rail compared to jumping on an airplane or taking road transport. Fast forward to the current decade, and we're seeing massive construction of new lines, not just in Europe and Japan, but particularly in China and Korea. What this really shows us is that there is a massive 50-year global head start in high-speed rail development, where the engineering and design have been constantly tweaked and perfected.
360 kilometers per hour. Just let that sink in for a second. For context, widespread commercial experience over the last few decades has mostly hovered in the 250 to 320 kilometers per hour range. But enormous advancements have taken place, and recently opened lines are pushing the boundary to a blistering 360 kilometers per hour. That sheer number perfectly highlights the immense technical mastery achieved globally over the last half-century.
Moving right along to Section 2, India's high-speed opportunity and the critical gap that exists today.
Now, this 8 to 9% annual economic growth rate, that is the real engine driving the story here. High-speed trains, they aren't just for show. They are vital arteries for commercial and administrative hubs. With India's vast size, its massive population, and this rapid 8 to 9% economic growth, the transport needs between centers of production, trade, and commerce are literally increasing day by day. This booming economic reality is the ultimate justification for needing a high-speed infrastructure. You just can't move a modern, hyper-growing economy on legacy transit speeds alone.
And this brilliantly illustrates the divide. If you look at most countries with major railway transport systems, they utilize a four-tier setup: conventional mail and express trains, freight trains, suburban systems, and that all-important fourth tier, high-speed corridors. India handles the first three beautifully, but completely lacks the fourth. Meanwhile, neighboring Asian countries like China and Korea have aggressively adopted high-speed corridors in a really big way, leaving India far behind in this specific tech. It is absolutely high time for India to add this missing piece to keep pace globally.
Now, it's not that the idea is brand new to India. Actually, initial thoughts for high-speed corridors started way back in 1987. But, well, it just didn't lead to any desirable progress. It's really only in recent years that definitive steps have been taken by Indian Railways to identify potential corridors and commissioned reputed agencies to figure this out. Now, in the present, those feasibility studies are officially underway. So while the realization happened decades ago, practical execution is only just beginning right now, and that is bringing Indian engineers into a completely new field.
All right, Section 3, coordinating the global network, and specifically the role of the UIC.
So you might be wondering who actually manages the insane complexity of this worldwide transport evolution. Well, enter the UIC High-Speed Group. Think of them as the global architect for high-speed rail. Their entire remit is to coordinate the activities of different countries. They don't just help build isolated tracks, they create a true harmonized high-speed network worldwide. When a country like India decides to develop high-speed transport, they aren't working in a vacuum, right? They rely on the UIC to facilitate interworking and share decades of established knowledge.
The UIC provides support across 5 massive areas: technical harmonization, operational exchanges, commercial strategies, economic planning, and financial structuring. And I really want to highlight that last point. Developing these incredible networks requires effective modes of financing and associating all the different sectors that end up profiting from this type of transport. The UIC helps member nations navigate not just the nuts and bolts engineering, but the deeply complex economics of these megaprojects.
Which brings us to Section 4, the anatomy of high-speed rail. It is a highly complex system.
So, the crucial point here is that high-speed rail isn't just about laying down faster tracks. It's a massive web of 9 interlocking, state-of-the-art components. Sure, you've got the physical infrastructure and the rolling stock, the actual trains. But you also need totally new operation rules and advanced signaling systems just to handle speeds of 300+ kilometers per hour safely. Then you add in marketing, highly specialized maintenance systems, massive financing structures, complex management protocols, and brand new legal aspects. Every single one of these 9 components has to work together flawlessly.
And because mastering those 9 distinct systems is so incredibly complex, we face this sobering reality. A high-speed corridor is completely a new field for railway engineers in India. Practical experience in this specific, high-stakes arena is just not currently available domestically. Mastering these systems isn't just a simple software upgrade, it's a monumental, ground-up task that requires an entirely new tier of engineering and operational expertise.
Finally, let's talk about the payoff in Section 5, the passenger experience and its unmatched performance.
Why go through all this effort? Because high-speed rail heavily outcompetes traditional air and road transport by delivering on these 5 core performance supports. You get high commercial speed, which results in a remarkably short total door-to-door travel time. There's a high frequency of available transports, meaning you aren't waiting hours for the next flight. The price is totally comparable to other means of travel. And crucially, high-speed trains are statistically the safest transport medium available today.
Plus, it offers unmatched reliability and accessibility. Think about the last time you had to fly somewhere. The weather delays, the hours spent standing around airport check-ins and security queues. High-speed rail works almost completely independently of the weather, and the accessibility is just incredible. It allows for spontaneous boarding. You can basically walk into the station and get on the train, which gives a super high level of flexibility for the modern traveler.
Now, what's really interesting about this onboard experience is that it essentially boils down to one word: freedom. Unlike being crammed in a plane or a bus, there's a significantly higher level of comfort when it comes to space, acceleration, and low noise. During the trip, you can go everywhere, anytime. You can hit the restaurant, go to the lavatory, or simply promenade down the aisle. Seatbelts, not necessary. Electronic devices, they're never limited. It's absolute freedom, all while traveling at 300 kilometers per hour.
So that brings us to our final thought. As India plays catch-up in a highly complex engineering field that was established globally over 50 years ago, we really have to ask ourselves, can any country truly claim to have a fully modern transport infrastructure without mastering high-speed rail? Understanding the basics of how these networks are constructed and maintained is just the very first step in answering that question. Thank you so much for joining me for this explainer, and I hope this foundation leaves you eager to learn more about the incredible engineering behind these high-speed marvels.